2007, step 2, question number 1, also question 7 from the Miscellaneous Pure step 2 support module. It's about binomial expansion, which is great because everyone loves binomial expansion. We do need to know the formula for negatives and fractional powers because you don't have a formula book, I believe, anymore in STEP. So you do need to go into the exam knowing that one, which I hope you do. Of course, every time we use this formula, we're going to replace n with a half in this case and x with k over 100. So let's just put that in. And we've got a bit of stuff to do here. Like obviously this makes 200 because on the bottom. This makes a 2 times 2 times 100 squared, which is 4 times 100 times 100. But then you also have to times that by 2 down here, so that would be 8,000, I believe, at the bottom down there. And then we'll have 8 times 1,000 cubed, sorry, 8 times 100 cubed. And then you also have to times that denominator by 6 to put it all the way down in the denominator. You will get a 3k cubed there. Sorry, you'll get a 3k cubed. The 3 is not cubing, of course. Be careful that you make sure these negatives go in the right place as well. So there's lots to do, but it doesn't end up being too bad. You end up with this. That's, of course, the first 3 terms up to k cubed. So, okay, well, what are we going to do with that then? Well, we can also simplify this 3 to the 48 there to make just 1 over 16, I guess. Okay, so what are we going to do with that now? So it says use the value of k equals 8 to find an approximation to 5 decimal places of root 3. So, okay, well let's put in k equals 8. I don't know why that's going to be helpful because I don't see a root 3 anywhere here yet, but okay, let's do it. Now, 8 over 200 is 4 over 100. And now this 8, one of these 8s can cancel with the 8 down here to get 8 over 10,000. And the reason these are both good is because making these decimals super easy. This is obviously just 0.04, and this is, I can't remember to count how many zeros there are, but you can count when you write it down. Now 8 cubed is 8 times 8 times 8. Now this is 8 times 2, isn't it? So I can cancel one of those 8s there. Also notice stuff is going on over here, where this is 100 over 100 plus 8 is 108 over 100. These 8s can cancel, so I'm doing stuff both sides of the equation now. And also 8 is 2 times 4, which can cancel with one of the 1 times 2 that comes out from there. So I cancel those. And now I've got down to that point I wanted. Over this number here is a super easy decimal to get. Just count back the decimals from 32, which is what the top is. Over here, 100 rooted is 10, and 108 rooted is just root 108. But that gives me my first hint as to where the root 3 comes from, because 108 is actually just 36 times 3. So this is super easy as decimal, and now we can put all those decimals together. Root 36 is just 6, so this is 6 root 3 over 10, and now we can see where the root 3 is going to come from. Borderline hardest thing about this entire step question is adding these decimals together correctly to get this. And we approximately equal this to enough decimal places here. Times everything by 10 and then divide by 6. And the actual hardest thing about the step question is doing a bus stop to actually work out what root 3 is. But if you follow it through, it roughly looks like this. And we have our answer to 5 decimal places, and we'll be good to go, I think. Maybe should I have gone to 6 to check that this doesn't round up or down? Maybe I should have. Maybe I should have. Except I couldn't have, right? Because I wasn't told to go any further than this. So we couldn't be more. So it's fine. It's fine. By choosing a suitable value of k, find an approximation for root 6. So absolute classic step things here. They've, in the first part, given you k as 8 to find a root 3. And now they're telling you to find root 6, but are leaving it to you to find what k value you should be using. So let's look over our work. Firstly, the expansion is the same, obviously, so that's okay. And this stuff goes together the same as it did before. None of this has been changed at all. But this is just going together. And now look at the previous thing. It's always about looking at the previous thing. How did this 8 magically turn into a root 3? Well, it did it because 100 plus 8 happened to factorize into 3 times a square number. It had to factorize into 3 because root 3 is what we wanted, but also into a square number because otherwise you'd end up with some other surd that was messing everything up. A square number rooted gave me a nice number I could then divide by later. So I want 100 plus k to be one of two things, or to be both of two things. I want it to be a multiple of 6, but also I want it to be a square number times 6. So okay, the best way to do this probably, and also I want to keep k small, because if k is big, then these terms don't go down, because there's probably lots of things I could use. But if k is very big, these terms don't collapse as quickly as I'd like them to, and the approximation is not going to be as good. So okay, let's just do 6 times the square number. 6 times 1 is obviously a long way away from maybe what I want to use roots. Well, 6 times 1 is 6, but it's a long way from 100. Like I'd have to use, to make this a 6, I'd have to use k as minus 94, which, no, I'm not doing that. 6 times minus 54, I'd have to use k as 46. Sorry, minus 44 for that. So that's not happening. That's too big. 6 times 16, the next square number, is 96. I'd only have to choose k as minus 4 for that. That seems pretty good. 6 times 25, I'd have to choose k as 50. So let's choose k as minus 4. It doesn't matter, this is negative. Minus 4 is relatively small. So if I choose k as minus 4, this will become a 96, which factors into 6 times 16, and that'll be a root 6 root 16, which is 4 root 16. Sorry, 4 root 6, and we'll be good. So let's choose k as minus 4, put it in. Minus 4 is fairly small. It also does a good job of cancelling with these guys, which is nice. So you can cancel it. You can do the same trick as you were doing before and cancelling stuff to leave 10,000s and things like that, because then the decimal is super easy. And also over here, of course, root 96, as we said, is going to be root 16 root 6, which is 4 root 6. Put those decimals together very carefully, and then times by 10 and divide by 4 using a bus stop. And you'll end up with some kind of answer there for root 6. And we'll be good to go. And last part, by considering only the first 2 terms of this. That's nice, right? We need to use the same thing, but we only have to do the first 2 terms, which is super nice of them. So it's just 1 plus, well, k is x, n is a third, and x is k over 1,000. So it's super easy. It's just going to be a third times 1,000 goes at the bottom, a third goes at the bottom. It's going to be 3,000 there, isn't it? And we want an approximation to the cube root of 3. So, okay, well, the cube root is up here. This is obviously 1,000 plus k over 1,000. So again, thinking about what we did before, we want 1,000 plus k to factorize, because of course when we cube root this, cube root of 1,000 is 10. We want 1,000 plus k to factorize into 3, because that will give us the cube root of 3, times not some square number this time, but some cube number. So, okay, let's just do 3 times some various cube numbers and check how close we can get, ideally small. So 3 times 125, that's a cube number, nowhere near. K would have to be minus something big. No way we're doing that. 3 times 216, closer, but not okay. This is 6 squared, by the way. 7 squared, 3 times 7 squared, 7 cubed, is this, which is only 29 away. Now that's, not tiny, but at the same time, if you're keeping your eye on the ball, you see the 29 right here and you go, well, okay, well, that's just what we're doing, isn't it? That's what we're supposed to be choosing. So we'll go with this. And also the next one will get you way over 1,000. So yeah, this is going to have to be it. So k as a 29 is what we're going to use. So we're going to put in 1,029, which we know factorizes to 3 times 343. Put k as 29 over there. That makes 3,029 over 3,000, which is obviously what we want. Cube root of this is 7, as we discussed and saw before. Times that by 10 to get rid of a 10 down, factor of 10 down there. And then divide by 7 to make this a 2,100. And we'll end up finishing this entire question. Thanks for watching, and I'll see you next time.